Hello YouTube audience, I'm trying a slightly different angle here. This might make me look more distinguished or just look ridiculous, probably the latter. Today I'm going to discuss the nature of infinity, and I'm going to try to get to some abstract, namely the abstract issue of the older Greek view of infinity as being something existing in potentiality, or finiteness as being the primary nature of reality versus, let's say, Cantor's view and the view of modern-day mathematical Platonism, which would be infinity as something actual. Before I get to that, I want to try to address at least one argument that the nominalist camp has been throwing at me as of late. And I have to admit to having not really come across this argument until very recently. So I'm going to try to address it as best I can. And my opponent claims that I misunderstand his argument, but I'm reading the literature that he's citing, and so the argument seems very apparent to me. But I'm going to address the argument as I understand it. The argument is the so-called indexing argument. And the argument suggests that the diagonalization argument of Cantor, and if you're not familiar with it, I don't have time to explain it. You're going to have to familiarize yourself with it. Those of you who want to skip to where I talk about the more philosophical issues may do so. But for those of you who understand the diagonalization argument of Cantor, the objection posits that there's a kind of pre-Copernican element to Cantor's argument, that there's, you notice where I have the diagonal of Cantor, where it forms, this is, let's say, all numbers between 0 and 1. Most of you have seen this, and you have an infinite number of y's. This should have had a ... You know what I'm saying? Y1 through y off naught. You have all the possible countable numbers between 0 and 1, and then Cantor established through a kind of proof by contradiction, or I would claim that he did, that the actual numbers between 0 and 1 are uncountable. And of course, for those of you who are familiar with it, he took the diagonal that cuts right down through the rows, y11, y22, y33, y44. Then he added 1 to each digit, or perhaps the 9s became zeros, and he formed a number that was unique and that could not be any of the other numbers between 0 and 1, thereby establishing a contradiction in the notion that all numbers between 0 and 1 are countable. I finally got down how to explain that really well. I've been struggling how to reduce that to a few simple words. But the objection says, well, what about something that starts, what if you take the wrong index? This is my understanding of the argument. I think it's patently ridiculous, but if you start with the wrong index, and you won't get uncountability, because you'll have, well, y13 plus 1, y34 plus 1, I skipped 2, 3. What did I do? Okay, well, y3, it should have been 2, 4, excuse me, y13, y24, y35, so forth. In other words, what if I start off at some other index? Well, at that point, you have not established uncountability. Now, my first objection, and that's my understanding of the indexing argument based on the way it was explained to me in the literature. Okay, if there's some deeper issue there and I don't get it, feel free to post a comment. As long as it's respectful, if there's personal attack, I block automatically. Okay, no ifs, ands, or buts. Okay, so first of all, if Cantor established an argument for uncountability that starts in the form of, if you can create a string different from the others, then it's uncountable. Okay, if A, then B. Well, if it doesn't thereby follow from logic, if not A, then not B. In other words, if there's some other index that doesn't arrive at the same result, then it's countable. That's not a positive proof of countability. It's not something where you're actually proving that real numbers are countable with respect to natural numbers. It's only if you establish an if and only if argument, and this is formal logic, it's simple logic, only if you establish that this would be an if and only if A then B, then not A, therefore not B. But it is not true that if you say if A then B, if your particular diagonal if it can be modified in a way that creates that you know that you have a number different from all the other numbers, then uncountability. It doesn't mean that if there's some that if you some other index doesn't arrive at the same result, then it's countable. That's not true logically. But even more to the point, I could start off at any index and move the digits over. Let's see, right here I started off at, looks like it's the 3rd place. I could easily start off with my string y13, and I'm sorry, that should have been y, whatever that is, 2, 4, but it doesn't matter, okay, whatever the string is. I wrote that down wrong, I apologize. I could easily move it over 3 places, and the Hillebert's Hotel paradox. I could easily move it over 3 places and just fill in, let's say, all ones in my first 2 places. And sure enough, I have a string that would work. The string, and I could do that on any index I want. If I have an index that skips spaces, like it starts at 1, goes to 3, goes to 5, well, I'd have to get creative about it. I'd have to fill in between the 2, and then I'd have to fill in maybe a 1 for the 4. As long as I get them to line up so that my nth place here is the same, my nth place on the string is the same as my nth place on the first number, then, let's say n, I start at the nth place on the string, then my nth place on the string is the same as my nth place on the first number. I can literally construct, and I did using hyperreals on the last one, but it might have been a little too obscure. We keep it simple, okay? So I think that addresses a particular argument of, let's say, Zenkin and the Nominalists, but at least I believe it does, okay? But I'm going to go to their more general, as I understand their argument. And my opponent seems to claim that I don't, but I'll let you, the viewer, decide. The more general argument has to do with and I'm sorry, I might have to make a part 2 of this. It's getting close to the 10-minute limit. The more general argument is on the nature of infinity is this, and I'm sorry you had to wait till the end, and that is the whole potential versus actual debate. I believe that it's completely null and void for one simple reason. And I'm going to actually get to that reason in part 2 because I'm coming up. It deserves a whole part 2 to this video, and it deserves more time. And so for the philosophical argument, I'm sorry you had to wait this long. Let me go to part 2.